Welcome everyone. So today what we'll be looking into is a broad aspects of the STAAD, starting from the history of how STAAD has been developed and till date what advancements have been made. And then we'll see why we really need the software STAAD Pro in our industry. Then we'll check out how the civil engineering aspect is basically connected with STAAD. Why is it so important for the civil engineers, the practicing engineers, to know about the software? Then we'll discuss about the working aspects of STAAD, primarily the interface and the different segments of the software. Then we'll discuss about the close associativity of STAAD Pro with other civil engineering tools. And finally, we'll take up a quick problem. We'll see how easy geometric modeling of a problem can be done in the software, and we'll also talk about the different alternatives of modeling a particular problem. And meanwhile, at middle stage, we'll have some questions, and also we'll have the question and answer session at the end as well. So moving ahead. So STAAD, as you know, it stands for Structural Analysis and Design. So the title itself, reflects the importance of the software, this particular industry. So it was originally developed by the Research Engineers International in California, and which was after a certain extent of development, it was commercially accepted by Bentley Systems, and it's till date being promoted by Bentley. Okay, so now let's discuss why do we need STAAD Pro. The people who are currently into the industry, they might be also aware that there are many other software which are available, and different industries use different softwares for a particular job, like ETABS, MIDAS, there are ANSYS, SAP, and lot many more softwares. So, but why STAAD Pro? If you look into the web, you'll see that STAAD Pro is one of the very common softwares which is accepted widely across the globe, and it's very common software which is which the recruiters seek in your resume as well. So why it is actually so common and so important? The first reason is, of course, every software which a person is using, whether it's me or any other person, would like to have a software that is quite easy to use. So STAAD provides us such an interface where you can model problem graphically. Okay, there are options to graphically model this problem. You can use the editor mode, which is also very user friendly, because the syntax which is being used by STAAD is quite close to the common interacting language. So that becomes very important. And the other important thing is, in addition to the in-house modeling options provided by STAAD, you can also take help of Excel, because Excel is also a popular tool which most of the offices or the in our day-to-day life we use it. So STAAD provides a very good compatibility with this Microsoft Excel, and you can model a problem partly or completely using Excel as well. Another thing is, depending upon the situation or a given problem, we engineers need to analyze a particular problem in different ways. Some of the problems need a simple static analysis, the usual analysis which we are taught in our engineering courses. However, some of the problems need to have some nonlinear analysis, some second order analysis, which we also refer to as p delta analysis. Then there are other specific types of analysis involved, like the buckling analysis for some compression members. If you are analyzing some cables like the cable stayed bridges, we need to have some specific analysis for that. If there is some material imperfection, there are analysis required for that separately. Then we have some pushover box analysis. So all these options are easily provided by STAAD. So this helps to model and analyze a problem depending upon the situation and the requirement very easily. Then STAAD has wide library which supports a wide range of design codes And not only it supports those codes, it's also quite closely linked with the research wing of these standards. So you'll see that always there are this updation being carried out in the library of STAAD, which helps us to keep it up to date with the latest design requirements. Then again, there are options of using different range of materials, which can be from the set of predefined materials, and also depending upon our requirement, we can modify those material properties to suit our engineering requirement. So this is a great flexibility that is being provided by the software. And then we have a lot of predefined options for the geometries, for the materials, for the boundary conditions or the supporting conditions. And we have quite a bit of flexibility to modify them depending upon our given situation. Every engineering problem is modeled by using some simple structural elements. So STAAD also uses the same philosophy, and it breaks our complex problem into a set of simple elements, which varies from use of the line elements, the plate elements or the two-dimensional elements, and the three-dimensional block elements or the solid elements. And a particular model can be developed as a combination of these three elements, and then that can be analyzed. And as we know, engineers' responsibility doesn't end with just solving or modeling a problem and then solving it. We also need to have a presentable format for our engineering problem that can be read by the other parties involved, and that can be easily conveyed to the end user. Okay, so STAAD provides a very beautiful interface to generate the report, to combine the contents of our analysis, contents of the design, and present it as a compact report format. So that's very important. Next, coming on to the connection or the link between civil engineering and STAAD. In our engineering courses, whether it's graduation or the post-graduation courses, we are taught with the basic structural analysis. We're taught with the properties or the strength of materials, and we're taught with different design aspects of those structural elements. But as we enter into the commercial world or the corporate world, suppose if you're given a problem of analyzing a multi-storied building. If I get back to our engineering courses, there were different methods like the substitute frame methods for analyzing the vertical loads. We had our portal or cantilever methods for analyzing the frame for horizontal loads. Then again, we have to compute the wind loads or the seismic loads, which are very common in design of the building structures. So we have to apply it separately. We have to compute all those detailed distributions manually. And then we have the moment distribution methods to compute the stresses in each of the members. So that was quite a cumbersome and a tedious way of doing the job. Then these softwares like STAAD help us to sort out this problem and reduce the tedious computations to a simple set of commands. So that's the very important and very useful tool. Next, what comes into picture is the frequent changes in the input data. So as a practicing engineer, I know very well that at different stages of design, because when we are doing a commercial project, there are different stages of design depending upon the availability of the data. Because when you are working on a project at the initial stage, you might not have all the informations available to you. So what we generally do, we assume a set of data initially as a preliminary design data. We use those data to get a preliminary design for the problem. Then at a later stage, when we have another set of data or the refined informations from the client, we have to reanalyze the same problem using those refined data. So these things keep on repeating. So just imagine if you have to do all those things on pen and paper, it's very difficult. And STAAD provides us that interface. You can save a same file, you can work on the same editor and have different set of data ready with you. You can switch between those data and simply refine your design. So that's very important. Then STAAD also provides us, due to its different available library functions, it has really helped us to arrive at solutions which are more economic these days, instead of having those bulky structures and the conservative solutions that we used on earlier days. So it really helps, because just imagine the bridge. You all guys must know Howrah Bridge of Calcutta, iconic structure. But from structural point of view, I would say the material consumption and the amount of work that was done, and if I compare that bridge with a similar bridge which is built on the same river as the Bali Bridge, it's a cable stayed bridge, just for information. So that bridge and the Howrah Bridge, if you compare them, you can easily understand the difference in the amount of material or the engineering solution that is provided. So this is really not a matter of pen and paper calculation. You need to have a particular tool that helps you refine your solutions, the design results, and get to the most economic solution. Next, STAAD provides option for exploring the new materials with their diversified use. As I'll just show you an interface just after this, that the material palettes that are provided in STAAD, that can be easily varied depending upon our requirements. So just if you want to even check a problem of strength of material, you can do so by varying the engineering properties of the material very easily. Now, STAAD again becomes very important when you are working in a commercial project that involve different parties. I, as a practicing engineer, I have worked with different projects where there are people who are involved into the detailed design, then people who will check your design, and then finally a party who will give you the final approval or go ahead for the execution of the project. There are different softwares available in the market, but if you ask me, STAAD is one such software which is known by most of the people in the civil engineering industry. So while working with a project, STAAD becomes the basic tool that is acceptable for all the parties. So that really helps, in getting projects, in working on different projects and getting approvals easily. So that's very important. And next thing is, the most important need of the industry is you have to deliver a project timely, in safe, economic, and feasible manner. Okay, so for timely delivery, you need quick approvals, you need quick solutions, and you need to get a refined solution from your end. So STAAD plays that important role of getting these benefits. Okay, next we'll see working aspect of STAAD. Now, how you can simply divide the interface of STAAD. So as you can see, any civil engineering problem can be basically divided into three broad aspects. One is modeling the project. You have to break the mathematical problem into simple elements. You have to generate the model. Then comes the analysis part, which is very well related to the structural analysis that is taught in an engineering courses. And then comes the design part. So STAAD is a software where you can do these three things, and you can segregate independently. Like in some of the projects, what we do is we use spreadsheets or in-house sheets for doing the design part. So instead, what you can do is you can model a problem, and you can just get into the geometry and analysis part. You can leave the design part aside. You can take the informations from your analysis, and you can use it as a input tool for your in-house spreadsheets or in-house softwares. That is a flexibility provided. Okay, and I'll just show you how. This is just a sample problem I've already created. Okay, so if you see, this is the basic interface of modeling our problems in STAAD. So just like if you use Microsoft Office tools like Excel and Word, you can find this, the interface is quite similar to what we're using in usual document editing softwares. You have this views, You can rotate your views, you can check different angles of the structure. You can have a 3D rendered view, which will help you see the model if elements or the different items that you have modeled are correct or not. Okay, then you have the design, the geometry aspects. You can see there are different elements that can be used for modeling a problem, and you can combine all those things together. Then we have the general tab. You can assign your materials, you can assign the loads, supports, material specifications, and the material properties. So all these things are very easy to handle because all those tabs are provided right near your working model. Okay, where at last we'll just use all those things and we'll see how quick we can model this portion. So what happens is, what we are seeing right now is the modeling part, because this is the section where we can do our modeling. Then after we go into the analysis part, there is an option where you have to run the analysis. So if you simply run the analysis, sorry, there is some error in this. If while you are modeling something goes wrong, you can check in the error tab and quickly resolve it. It's very easy. For the time being, I'll delete those plates. You see, this is the analysis section where STAAD is using its engine to solve out the problem. Now, once the problem is solved, we can go into the post-processing mode. And this is the region similar to the geometry tab where we can see the results from the basic things like the bending moment diagram, the axial force diagram, which is scaled up rightly, and I can see the shear forces, the deformations. This is the graphical interface of the details. If you want the tabular format, you have it right away. Okay, it will give you the summary of each of the elements. If you want specific beams and want to check their details, you can have it here. You can sort it out depending upon your requirement. You can have the results for specific load cases. So suppose if I want just for the first two load cases, that will give you the details. These all things can be copied and you can take it into Excel, use it for your in-house softwares if you are using them. So this is the flexibility. Again, if this is just the analysis part that is done, if you want to do the design, you can have the design of selected members. You can have the entire structure designed depending upon the requirements of your codal provisions. You see, you have a number of different codes that is supported by STAAD. Now these codes, the for design part, let me tell you that the commercial version of STAAD, you need to have license included for specific codes. So that's one important aspect. So depending upon your requirement, you can purchase the license and have the design part. Now, in the latest versions of STAAD, they have provided some third-party interfaces with the RAM. These are the interfaces which are linked with external plugins that help you design the end connections, which is very common for the steel industry. They provide specific sorry, see, this is one interface where they'll take you to the third party interface and can have a detail of the connections end to end. They provide us interface with building planners, which are mostly used by the architects and the civil engineers for residential buildings or commercial buildings. Then we have interface for the piping teams. We have specific interface for modeling and designing the bridge decks. So these are additional, interfaces which you might use, might not use, depending upon your requirements.